All right, today we're going to go over the law of sines. So everything that we've done so far with trigonometry, you've had to have a right triangle. But when we get into the law of sines and eventually the law of cosines, you don't have to have a right triangle. You just got to know a few things about the sides and the angles. So if we look at this, I'm going to draw a right triangle here. Sorry, not a right triangle. It doesn't have to be a right triangle. It could be an obtuse triangle. So we'll say that this angle up at the top, maybe it's 90 degrees, maybe it's less, maybe it's greater than. It looks like it's greater than. We can say it is for right now. I'm going to call the angles A, B, and C. And I'm going to call the sides across from those angles little a, little b, and little c there. So here we have the law of sines. And the law of sines simply states this. If you take the sine of angle A, remember inside the parentheses we always put our angle, over the side across from A, that's equal to the sine of B, angle B that is, over the side little b. And we can extend it further if we want and say that equals the sine of C over little c. So for any of these, notice we've got three fractions here. We've got one dealing with the A's, one dealing with the B's, one dealing with the C's. You only really need two at a time. And you only need one equal sign, but really any side you pick, you put it underneath the sine of the angle across it, it equals a different side underneath the sine of the angle across from it. So let's look at a problem and we'll try this out. So let's see. Let's suppose we have this triangle right here. We'll call this B up here, C and A. Suppose A is 33 degrees, B is 105, and the side across from B is 37.9. This is little a and little c here. And we want to find the rest of the sides here. Well, to find for side A, I'm going to say, okay, I've got the sine of big A, which is 33, over little a, should be equal to, now we're going to choose the fraction with B's or C's here. Well, if you look, you don't know what angle C is. We could quickly find out. So if we wanted to, we could find out that angle. But we also don't know what the side C is. We know what the angle B is, and we know the side across from it. So it makes it pretty convenient to choose when you be talking about the sine of big B, which is 105, over little b, which is 37.9. Now, from here, we're going to cross multiply. So I'm going to say the sine of 33 times 37.9. That gives me 37.9 times the sine of 33 is equal to A times the sine of 105. And you can punch this side in the calculator if you want. And sometimes that kind of keeps you from making mistakes. So I'll go ahead and do that. Make sure your calculator is in degree mode because we're talking about degrees here. You take 37.9 times the sine of 33. That gives me 20.64. That equals A times the sine of 105. Divide both sides by the sine of 105 now. Excuse me, my voice is squeaking a little bit. Sine of 105. Those guys cancel. And 20.64 divided by sine 105 gives me 21.36. That equals side A. Now we need to find C's, the values for C's. So pause the video. Before you pause the video, how do you think you can figure out angle C? If you look at this, we know that this is 33, that's 105. You're going to subtract those from 180. So 180 minus 105 gives me 75. And then when I subtract 33 from that, you get 42. So that's angle C. That was pretty easy. So now I can say the sine of angle C, which is 42, over the side across from him must equal, and I'll just stick with angle B here since we already know the side across from him, and it's pretty exact compared to here. This is a rounding down here for A. So it doesn't matter, you should still get pretty much the same thing. The sine of 105 over 37.9. I'm going to cross multiply these two. 37.9 times sine of 42 gives you 25.36. That equals the sine of 105 times C. Divide both sides by the sine of 105. And I get 26.25. And that's your value for C. We got A and C. Let's try one more, and I think that should be enough to get you going with law of sines. So suppose I gave you a triangle like this. Let's say that this angle is 40 degrees. This one is 70. And let's see, this side is 20 degrees right here. That's it. I want you to figure out the rest of the information in this triangle. So I'm going to call this X, this Y, and this Z. Now notice this time I'm not labeling them A, B, and C, because not every triangle in the world is labeled A, B, C. So don't say, hey, that doesn't fit law of sines. Remember when you did the Pythagorean theorem, you said the Pythagorean theorem is A squared plus B squared equals C squared. Well, a lot of times we have triangles that don't have A's, B's, and C's in them. They're X's and Y's, and we just let A be X and B be Y and so forth. So we're going to kind of do the same thing here. If it helps you, you can label some of them A, B, and C. I don't care. But really the main thing behind this is just saying, pick one side, take the sine of, say, 70, and put it over Y. And go from there. I'm not going to tell you the rest. I want you to pause the video for a second and try this out. All right, should have paused it. You should have your answer ready. If you didn't, pause it. I didn't give you enough time to pause it. Try it out. I'm going to start by just writing out what I know here. I know 40 degrees right here and the side across from it. So I'm going to use that to pretty much solve for Y and 70 here. So we've got the sine of 40 over the side across from him, 20, is equal to the sine of 70 over the side across from him, which is Y. There's only one variable in that, so that's a good thing. I can cross multiply and solve. I get Y times the sine of 40 is equal to 20 times the sine of 70. Divide both sides by the sine of 40. Notice this time I'm doing it a little bit different. It doesn't really matter. I'm just going to punch it all in the calculator at once, because I know some students will do that. So you get Y equals all of this right here. So when you punch that in your calculator, be very careful, because some students forget that if you're typing in with me 20 sine 70, you need to make sure you put a closed parentheses right here after this 70. If you don't do that, you'll mess it up. Divide it by sine 40, and you should get 29.23. That's your value for Y. To find Z, well, Z is a little bit easy. It's kind of like that last problem we had. Z is simply, well, 180 minus 70, which gives me 110, minus 40, and that gives me 70. So Z is 70. Now, you could use law of sines again, but notice if this is 70, let's use some of our geometry knowledge from the year. If that's 70, that means this is an isosceles triangle. So this angle equals this angle. And since it's an isosceles with the base angles being congruent, I know that the sides across from congruent angles must be congruent. So X must be equal to Y. We've already solved for Y. That's also equal to X. So now we've solved for both of them. You could have used law of sines again, but it makes it pretty simple. So that's the law of sines. I want you to try out your example problems. Let me know if you have any issues with those, and hope you have a good time.